Welcome you all. Today we are going to see HART, which comes under the subject title Industrial Data Communication. What is HART? HART is Highway Addressable Remote Transducer. It is a globally recognized standard used for sending and receiving digital information across analog wires between smart field devices and control or monitoring systems like PLC and DCS systems. Digital networking of HART facilitate to access any instrument, field device or controller for configuration and diagnostics from any point of network. It is an open source process control network that supports hybrid communication. It provides additional bidirectional digital communication channel over the same 4 to 20 milliampere signal wiring. So, HART protocol can be called as Smart Instrumentation Protocol, where the smart field devices communicate directly with the PLC with this protocol. So, the terminologies are there are primary master and secondary master and the slave. Primary master consists of control system, secondary master consists of handheld communicator or a maintenance computer. Slave can be a transmitter, sensor, transducer and attenuator. So, this diagram shows the primary master and the secondary master and the slave connected in the structure. HART provides two simultaneous communication channels, one analog, the other one digital. A 4 to 20 milliampere signal communicates the primary measured value as an analog value of current using the wiring that provides power to the instrument. The HART system then converts the current value to a physical value according to the parameter defined by HART software. For example, 7 milliampere can be converted to 80° Fahrenheit. Digital device information is communicated by encoding a digital signal, generally using a technique known as frequency shift keying on the same 4 to 20 milliampere wiring used for analog communication. The digital signal contains information from the device including PV, device status, diagnostics and additional measured or calculated values, etc. Together, the two communication channels provide a complete field communication solution that is easy to design, simple to use, low cost and extremely reliable. How HART works? HART is an acronym for Highway Addressable Remote Transducer. The HART protocol makes uses frequency shift keying (FSK) standard to superimpose the digital communication signals at a low level on the top of the 4 to 20 milliampere. This enables two-way field communication to take place and makes it possible for additional information beyond just the normal process variable to be communicated to or from a smart field instrument. So, this shows the HART communication, where from the field instrument the analog signal of 4 to 20 milliampere can be transmitted to PLC or DCS or input output device. At the same time, from the master instrument, it can also send a HART digital data to a field devices. So, the theory of the operation has principles behind the four types. One is communication modes, frequency shift keying, HART networks and HART commands. So, communication modes. So, first communication mode is master slave mode. During normal operation, each slave, that is field device, communication is initiated by a master communication device called controller. HART provides for up to two masters, one can be primary, the other one is secondary. The primary master is generally a distributed control system or programmable logic controller or a personal computer. The secondary master can be a handheld terminal or another PC. A slave devices can include transmitters, actuator and controllers that responds to commands from the primary or secondary master. So, this diagram shows the master slave communication mode. So, first master can be a DCS or PLC, which can give a request to the slave. Slave can be a field instrument. So, once the request has been received to the slave, slave will give reply to the master. So, this diagram shows master as a PC host application and field devices as a slaves and the secondary master as a handheld terminal. Burst mode. In burst mode, the master instructs the slave device to continuously broadcast a standard HART reply messages. Example, the value of the process variable. The master receives the message at the higher rate until it instructs the slave to stop bursting. It is also called broadcast mode, used for fast updating of the values of a measured variable. So, this diagram shows a master mode where the master and the slave will have a continuous response on the replies. Frequency shift keying. It is based on the Bell 202 telephone communication standard and operates using the frequency shift keying principle. The digital signal is made up of two frequencies, 1200 and 2200 Hertz, which represents the bit 1 and zeros. So, 1200 will be taken as bit 1 and 2200 will be taken as bit 0 respectively. Sine wave of these two frequencies will be superimposed on a DC analog signal cables to provide simultaneous analog and digital communication. Masters are connected parallel to field devices. So, devices can be easily connected or it can be disconnected and the current loop remains uninterrupted. So, this diagram shows the frequency shift keying where the 1200 Hertz will be taken as 1200 Hertz will be taken as bit 1 and 2200 Hertz will be taken as bit 0, and this sinusoidal signal will be represented as a digital signal and the straight line will be taken as an analog signal. So, these values will be ranging between 4 milliampere to 20 milliampere. HART network. First one, the point to point mode. Both analog and digital communications are supported. 4 to 20 milliampere signal is used to communicate one process variable. Additional process variables, configuration parameters and other device data are transferred digitally using the HART protocol. The 4 to 20 milliampere analog signal is not affected by the HART signal and can be used for control in the normal way. The HART communication digital signal gives access to secondary variable and other data that can be used for operation, commissioning, maintenance and diagnostics purpose. So, this shows the point to point network where the PC host application will directly have a contact with the field devices. And multi-drop mode. In multi-drop operation, the devices can exchange their data and measured values only via the HART protocol. The analog current signal serves just to energize the two wired devices, providing a direct current of 4 milliampere. It requires only a single pair of wires. Up to 15 field devices are connected in parallel to a single wire pair, and the host distinguishes the field devices by their preset addresses, which can ranges from 1 to 15. So, this diagram shows one master, which is a PC or host application, which can be connected to the slave to a multiple devices. So, field devices here it can be connected to 3. So, likewise it can be connected from 1 to 15. HART commands. The HART protocol is a request response communication protocol, which means that during normal operation each communication is initiated by a request from the host communication device. The host is generally a distributed control, a PLC or PC based asset management system. For example, the device is typically a field measurement device such as pressure, level, temperature, flow or the other transmitter. In order to make certain any HART enabled device from any supplier, it can communicate properly and respond to a command with the correct information. The set and the types of commands are defined in the HART specifications and implemented in all HART registered device. So, the types of HART commands are non-public, wireless HART, device specific, common practice, universal. In non-public, it can be used for the manufacturer use during the construction or the factory maintenance of the device. The commands designed specifically for wireless HART device are wireless HART commands. For device specific, it allows manufacturer to define their own HART commands to support the specific device functionality. For common practice commands, it is used for the best practices for the standards, operating procedures, example rearranging, calibration, and its optional can be used must conform to the specification. Universal commands is mandatory for all HART devices. The HART command set provides uniform and consistent communication for all field devices. Host applications may implement any of the necessary commands for the particular application. The command set includes three classes. Main three classes are universal, common practice, device specific. The universal, all devices uses the HART protocol must recognize and support the universal command. Universal commands provide access to information useful in normal operation. Example, reading the primary values, variables and units. Common practice command. Common practice commands provides function implemented by many but not necessarily all HART communication devices. Device specific commands. Device specific represents the functions that are unique to each field devices. These commands access setup and calibration information as well as the information about the construction of the device. Information on this device specific commands is available from the device manufacturers. So, coming to comparison of OSI model with the HART layers. HART layers can be classified into three layers. The physical layer will be compared with the Bell 202 and the data link to the HART protocols rule and the application to HART commands. So, between the network layer to the presentation layer, there is no layer present in the HART. So, HART protocols utilize the OSI 7 layers reference model. It implements only layer 1, 2 and 7 of the model. Layer 3 to 6 are empty as their services aren't needed or layers 7 can provide that. Physical layer connects devices together and takes care of the bit stream communication from one devices to another device. Data link is in command of transferring the data across the channel. It organizes the bit streams into packets and ensures the communication between the master and the slave devices. Application layer defines the commands, data types, responses and the status reporting which are supported by the HART protocol. The universal commands specify the minimum application layer contents of all the HART compatible devices. The advantages of HART. It is an improved plant operation and it is an operational flexibility, an instrumentation inverse protection and digital communication. Thank you all.